Okay, am I audible?
Yes, sir.
Okay.
Yes, sir.
Okay, just wait, I am starting. My whiteboard is visible, everyone?
Yes, sir.
Okay. Okay, so today we'll discuss the shifting property of jet transformer. Okay. Shifting property. Sometimes this property it is also called shifting theorem. Okay, so please remember these things also. Shifting property or theorem of jet transformer. So first of all, you have to know, we have learned in previous classes is the multiplication theorem, linearity theorem, and also multiplication of the polynomial theorem. So using these three types of properties, we have to apply it once again. Another one is the shifting theorem. So what is the shifting theorem? So I'm written here the shifting theorem presented here is also referred to as, and everyone please note down this theorem also. This is very important for your exam purpose. So the shifting theorem presented here is also referred to as the real translation theorem. That means if x of t is equal to 0, condition is, you know, that is for t is always less than 0, and this xt it has jet transform, one minute. So jet transform, that is also exit. We know that. So then we have to written, that is two parts. One is positive terminal, another one is the negative terminal. The first one is, that is z of, in third bracket, x of t minus mt is equals to z to the power. Anyone, any questions, or otherwise mute yourself? Z to the power minus n xz. Milinkit, please mute yourself. Okay. So this is the number one. Equation number one we have to written, and another one, it is positive purpose, that is z of x t plus nt is equal to z to the power n into x of z minus summation of k is equal to 0 to n minus 1 x into kt z to the power minus k. So this is basically another one. So these are the shifting property. So here you can see this is the basically two terms we have to shift it presented in the real transformation or real translation theorem. So when xt is equal to 0, condition is t is always less than 0. The value of t is less than always 0. So the z transform of xz, it is the basically two form functions. One is negative, another one is the positive. So please remember these two things. This is z of x t minus nt. We have to written this theorem, that is the z to the power minus n into xz, number one equations. And number two, z of x t plus nt, that is a positive functions. That is z to the power n xz minus summation of k is equal to n minus 1 x into kt z minus. Okay. So sometimes this equation you have to prove. Okay, मतलब ये prove करने के लिए अगर क्वेश्चन भी आ सकते हैं आप लोगों का सेमेस्टर क्वेश्चन. So here n is equal to basically this n it is basically, you have to know n is 0 or either it is 0 or positive integer. So please note down it where n is a 0 or a positive integer. Okay, so now we have to prove these equations. First we have to prove number one equations, that is a z of x t minus nt, this is equal to z to the power minus n x of z. So we have to apply the z transform in this into these equations. So we have to retain, that is z of x t minus nt, this is equal to summation of k is equal to 0 to infinity x into function is kt minus nt z to the power minus 2. So now you have to know. So this is the basically constant term z to the power here minus n. N is the basically integer number, you have to know either it is 0 or integer number. Okay. So now rest of the part, that is summation is a k is equal to 0 to infinite, that is x into kt minus nt z to the power minus k minus n, minus of k minus. Okay, so here this is basically one another equations, that is a equation number third. Okay, so here you have to prove, that is you have to put m is equal to k minus n. Okay, so you have to prove also m is equal to k minus n, and when this k is equal to 0, when this k is equal to 0, that means m is equal to minus n. Okay, so you have to prove these equations. You have to put this equation k is equal to k, sorry, m is equal to k minus n into these equations. So equation 3 can be written as that is a z transform of x t minus nt, this is equal to z to the power minus n, a summation of m is equal to minus n. So please here you have to show that is m is equal to minus n, because here k is equal to 0, that means when you have to put k is equal to 0, the value is m is equal to minus n. So that's why you have to written here the ranges, lower limit ranges is m is equal to minus n. Sorry, just wait. So m is equal to minus n to the plus infinite range. Sorry for that. Again it is also disturbing. that is m is equal to minus n to the power infinite. Okay, so the range is, you have to know, that is x of kt minus nt. Is it clear or not? Here you have to changes only the limit, that is the lower limit. So lower limit you have to know, one-sided Z transform method, it is ranges is 0 to plus infinite. And when it is also two-sided, that means the minus infinite to the plus infinite. So here k is equal to 0. So if you have to apply, that is k is equal to 0, that means the value is coming here, m is equal to minus n. Okay, so when m is equal to minus n, that is the lower limit, and higher limit it is the infinite. Okay, and rest of the equation it is also same to same, x of kt minus nt into z to the power minus of k minus n. Okay, so this is the basically negative of the shifting property of the Z transform. So now you have to changes. I'm written the next page.
Sir,
Yes.
सर वहाँ z to the power minus k minus n की जगह m लिख सकते हैं, minus k लास्ट में,
E to the power
z to the power minus m,
a to the power minus n.
z to the power minus n.
Yes, z to the power minus n. Yes, yes, yes. Here n is the basically integer. So that's why I am telling in the previous classes also, in the Z transform method, the constant term you have to no changes. This constant term it is also outside it in the first or earlier part. So that's why we have to written here z to the power minus n. Okay, and another part is the function of the x of something, that is here function of x of kt minus n. Okay, another form. So now, 1 minute. Now we have to written here, that is x is equal to that is x of mt is equal to 0 for when m is not is equal to, sorry, not equal to, that is a less than 0. So when n less than 0, that means we have to changes the previous value, that is n is equal to minus n, because the equation is previously m is equal to k minus n. When the value is k is equal to 0, that is m is equal to n. Yeah, m is equal to minus n. So the equation is coming finally, that is the transform of x of t minus nt. This is equal to summation of, and the constant term it is also written first, that is the z transform z to the power minus n, a summation of m is equal to 0 to infinite x of nt z to the power minus n. So the constant term that is also z to the power minus n, and this is the basically functions of the xt, and xt we have to represent in the z transform method, that is xj. So this is the final equation number 4. This is for the shifting property of the negative function, that is x of t minus nt. Okay, another functions we have to apply, and here you can see this is basically one multiplication theorem we have to apply. because z to the power minus n multiplied x of z. Okay, this is multiplication theorem. It is also applicable into the shifting properties also. Now we have to see another form, that is a positive functions. So what is the positive function? That is z of x of t plus nt. We have to written these equations, that is the summation of k is equal to 0 to infinite x of kt plus, here plus positive functions, that's why you have to kt plus nt into z to the power minus 2. Now that is the positive function, that means z to the power n, it is the constant term. Another summation, that is k is equal to 0 to infinite x of kt plus rnt, and z to the power, that is also changes k plus n. Okay, so you have to also put the another functions also in the positive function, that is minus of k is here k plus n. Now we have to apply the shifting rules, shifting property, that is z to the power n within bracket summation of is equal to k is equal to 0 to infinite x of kt plus nt into z to the power k plus n. Then again also, that is you have to know k is equal to 0, where lower limit one is n minus 1 x of kt z to the power minus k minus another one, it is also same, k is equal to 0 n minus 1 x of kt z to the power minus k, and so on. This process is continuing. Okay, because first you have to apply, that is k is equal to 0, then k is equal to 1, then k is equal to 2, and so on. This process is continuing. So the common term, that is z to the power n, it is a constant term. Rest of the function, that is the summation of k is equal to 0 to infinite x of kt into z to the power minus k. Another one, summation of k is equal to 0 in minus 1 x of kt z to the power minus k. So this is the basically two functions we have to written here. One is limit, limit is lower limit 0 to infinite. Another one is the k is equal to 0 to n minus 1. And this process is continuing. That is, in next term it is also coming n minus 2, n minus 3, and so on. So this is the basically linear equations or shifting property of the Z transform method. So you have to written this equation, that is z to the power n, and what is the value of this part to know, that is x of kt z to the power minus k. We have to written this equation, that is a z transform of xt. That means, just wait, sometimes my whiteboard it is disturbing, so that's why the unwritten part it is also detected. So we have to change this x of kt z to the power minus k. You know that is the x of z minus rest of the part k is equal to 0 to n minus 1 x of kt to the power minus k. Okay, so this is the another functions, which number, that is I think number 5 equations. Okay, So these two equations, please remember these things also. This is very, very important. One is the positive functions of the jet shifting property of jet transform method. Another one is the negative functions. Is it clear? So it is very much clear when you have to go the different types of examples. मतलब जब भी आप लोग examples को थोड़ा सा problematic examples को solve करोगे तो आप लोगों को थोड़ा सा याद आ जाएगा मतलब कैसा फंक्शन लिख रहा है कैसे कैसा आएगा. अच्छा, previous day we have solved one examples. Lastly the class is ended. It is solved or not? Question is find the jet transform of unit step functions that are delayed for the one sampling method or one sampling period of time. Another one is the four sampling period of time. ये प्रॉब्लम मतलब होम टास्क दिया गया था, आप लोग सॉल्व किए थे? Anyone? No one. वही नहीं किए थे? ओके, तो ये प्रॉब्लम को थोड़ा सा पहले इसको डिस्कस करूंगा. इसमें बहुत सारे प्रॉपर्टीज आप लोगों को इसमें फॉलो हो जाएगा. दैट इज मल्टीप्लिकेशन और शिफ्टिंग, एनीथिंग एल्स. So question is problem 1. Find the jet transform of unit step function that are delayed by one sampling period and four sampling periods. ओके, तो आपको ये ऐसे भी क्वेश्चन दिया जाएगा. यूनिट स्टेप फंक्शन का आपको जेट ट्रांसफॉर्म निकालना पड़ेगा. इसमें कंडीशन दिया है this system it is delayed by one sampling period, another one is the four sampling period. Okay, so now you have to know first we have to solve that delayed by the one sampling period. Okay, first is one sampling period. Function is that is z of that is 1 of t minus capital T. Okay, so that means we have to return the equation that is jet transform, that is a z to the power minus 1. This 1 is the for one sampling periods or delayed by the one sampling times, that is a 1, and jet transform of 1 of t. So now you have to return this equation that is a z to the power minus 1 into 1 by 1 minus z to the power minus 1. You have to know these functions because using the tables, that is the jet transform table, you have to put this formula that is z of jet transform of 1 of t. The answer is 1 by 1 minus z inverse. Now we have to multiply it, that is z inverse by 1 minus z inverse. This is for the one sampling method, that is the one sampling period. So here diagram it is coming, that is this is the xt, that is the t. This is a function of xt and this is a time of t. So you know that is 0 equal division. You know that the time gap it is also same, that is t, 2t, 3t, 4t, 5t, 6t and so on. And here 0, 1, 2 and so on. So this is a 2t, 2t, 3t, 4t, 5t, 60. So first of all, you know that this is for the delayed for the one sampling method. Okay. So one sampling method, the value is also, this is the one, then this is the two. Okay. So first starting from here, t, then this is delay. That means after 1 second, that means the first sampling period 0 to t, that is 1, this time gap, then the result is it is also stable or state line. Okay, so the function is here, that is 1 into t minus delta. Is it clear? This is the unit step functions for the delayed for the one sampling period. Another one, another part is 4 sampling period. This is same thing. 4 sampling periods. That means Z transform of here 1 into t minus 4t. Okay, so please remember this. So here also z to the power minus 4 into Z transform of 1 of t. Now you have to written this equation z to the power minus 4, and this is the same thing, the formula from the table 1 by 1 minus z to the power minus 1. Then you have to written these equations, that is z to the power minus 4 divided by 1 minus z inverse. And graphically you have to represent, this is the xt, this is the t, xt, this is the t, this is the 0, t, 2t, 3t, 4t, 5t. And you know that this is the xt, first 1, then 2, and so on. So this is the basically 4 sampling period. That means 0 to t, 1, then 2, then 3, then 4. That means this purpose. That is 4t. And then it is stable like that. Okay. So this is the function 1 into t minus 4. So here you can see this is the basically delayed by the 4 timing or 4 sampling periods, and here delayed by the 1 sampling period. Is it clear? So using this sampling theorem or shifting property, you have to shifting the different pulse of the signal for the discrete time control system. Okay, that means when you have to go the continuous signals, it is uses, it is continuously input is given. Sometimes it is also delayed by the these delayed type of circuits we have to use. Okay. Is it clear, all of you?
Yes.
Another question, another example, problem 2. Problem 2. A question is given, obtain the Z transform of, आपको फंक्शन दिया गया है, that is f of a, this is equal to two functions, that is a to the power k minus 1, another one it is also 0. So when a to the power k minus 1, here k is equal to value is 1, 2, 3 dot dot dot, and when f of a is equal to 0, condition is k is always less than equal to 0. ओके, सो ऐसे आप लोगों को क्वेश्चन दिया जाएगा, ऑब्टेन द Z ट्रांसफॉर्म ऑफ दिस पर्पस. ओके, f of a to the power k minus 1 and 0. Okay, so this is very easy, no difficulty. How it is solved? Now, we have learned in previous equations, that is the shifting property. One is negative and another one is the positive purpose. So we have to retain in previous shifting property, that is the Z transform of x of k minus 1. This is equal to Z inverse x of Z. Okay, now the Z transform of a to the power k is, we know, because we have to solve in polynomial function in previous classes, that is Z transform of polynomial function, that is a to the power k. It is formula from the table, that is 1 by 1 minus az inverse. This is z, az inverse. So now we have to retain these functions, that is z of f of a. This is equal to z transform of a to the power, first is a to the power k minus 1. Another one is 0. It is also 0. You know that. So z inverse, it is the constant term. Then the function is 1 by 1 minus az inverse. That means z inverse by 1 minus az inverse, where k is equal to 1, 2, 3 dot dot dot. Okay. So this is the basically simple problem. So when k is equal to 1, that means here you can see k is equal to 1, that means 1 minus 1, that means a to the power 0. A to the power 0, that means 1. So answer is coming z inverse. Again you have to put k is equal to 2, that is 2 minus 1, that means a to the power 1. A to the power 1, that means the function is coming this z inverse by 1 minus a z inverse. So if you changes the value of k is 1, 2, 3 and so on, this value it is also changes. Okay, and another function, if it is equal to 0, this 0 you have to know the when it is 0, that is k is less than equal to 0. That means the value of k either it is 0 or less than 0. That is point functions or anything is else. Okay. So this type of simple problem it is coming in your exam purpose. Now, next another problem 3. Consider the functions of yk, which is a sum of function that is x of h. This is h, where h is equal to 0, 1, 2 dot dot, that is k, number of terms is k. Okay, such that is y of k, this is equal to, sorry, h is equal to 0 to k, because you know that this is the lower part, there is a lower limit, h is equal to 0 and higher part is k. So that's why you have to written here h is equal to 0 to k. Okay, function is x of h. Here also written k is equal to 0, 1, 2 dot dot. Now, where yk, this is 0 for when k is equal to less than less than 0. Obtain, question is obtain the Z transform of yk. ओके, सो ये आप लोगों को क्वेश्चन दिया जाएगा, जैसे कंडीशन दिया गया है, वैल्यू ऑफ h 0 to k, फंक्शन इज y is equal to k of x of h. सो ये कंडीशन में आप लोगों को Z ट्रांसफॉर्म को निकालना पड़ेगा ऑफ y. So this is very easy. So first of all, function that is yk, it is equal to limit we have to apply it 0, 1, 2 and so on. So first function is x of 0 plus x of 1 plus x of 2 plus dot 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 dot. That is the another previous one, that is the x of k minus 1 plus x of 2. Is it clear or not? This is the basically different value of h, that is the h functions. Okay, h value is 0 to k, first 0, 1, 2 and so on. Last term is x of k. Is it okay? No one is response. Is it okay or not?
Yes, sir.
Then
Yes, sir.
another one, y of k minus 1, the function is also 0, x of 0, then x of 1 plus x of 2, this is a x of 2 plus dot 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 x of k minus 1, because here the limit is, that is k minus 1. So the last is x of k minus 1. Now we have to calculate, that is hence y of k minus 1 is equal to x of k, where k is equal to 0, 1, 2 dot 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 dot. Okay, now we have to put the value. Yk. What is the value of yk? This one minus the value of y of k minus 1. This is the basically y of k minus 1 value you have to put it. So here you can see this is a negative sign. That means this x0 cutting down, x1 cutting down. It is every term it is cutting down. One is term is represents here lastly, that is x. You know that because here you can see these are the all same term it is present in the function of yk. Another one is the y of k minus 1. Is it okay or not? Please respond. Is it okay?
Yes, sir.
Yes. So now we have two equations. We have to written that is a z transform. We take the z transform in the both side. That is y of k minus y of k minus 1 equals to z transform of x of k. Okay. Now next page. Everyone write your own name and roll number in the chat box also. And Pranab is present.
Yes, sir.
You take a screenshot right now.
Okay. Yes.
So the final equation is coming from here, y of z, that is z to the power minus 1, y of z is equal to x of z. So we have written these equations. Here you can see y of z, it is common part. The required function, that is 1 minus z to the power minus 1. अच्छा, अभी आप लोगों का क्या दूसरा कोई क्लास है? प्लीज रेस्पॉन्स एनीवन?
No, sir.
मतलब 12 से कोई की क्लास है, मतलब किसी टीचर का 12 बजे से?